be going through a bit of presentation of around 30-40 minutes, and then we'll have interactions with questions and what are your challenge areas and what you're looking for in flood modeling areas. So you can stop me when I'm talking. You can just stop anywhere during the presentation and ask questions. So basically about myself, I'm Rishi. I'm a postgraduate I've done in IIT Guwahati in 2016. And post that, I had worked in various MNC companies, primarily working on flood modeling. And that is when I had got acquainted with TwoFlow models and doing a lot of hydraulic modeling with TwoFlow with UK, Australia, and UK and US. So it's very popular in Australia and UK primarily TwoFlow, and more or less in US going to be now. And after that, I have started to work as an independent consultant currently, and as well as a TwoFlow lead in India. So I'm responsible for training, support, and all branding of TwoFlow in India. So if you have any future questions on TwoFlow, or you want to work on TwoFlow, or you want support with TwoFlow, you can contact me for your flood problems. So I'll just share my screen, and you can let me know when you can see that.
Yeah, sure.
1 second. Yeah. Yeah, I think you
Yeah,
can see now. Yeah.
yes, we can say that.
Okay. Yeah. So I'll get started. Okay. Yeah. So So in this presentation, I'll just go over what is TwoFlow and what are the products which TwoFlow develop and what makes TwoFlow separate from others in the flood modeling, like commercial flood modeling space, and what are some of the applications of TwoFlow which was used in primarily in Australia, which I'll be showing in these slides. But there are a lot of works which are done in India as well. But I can show that in the next other presentations if you want. And this TOEFL modeling framework, I won't be going into this now because it is more into training and how to, what is TOEFL model setup and all. So this is more of training part when I give, you can go through this. But as of now, I'll be covering the first 2 points. So, like what is TOEFL? TOEFL is something like which develops and markets and sells state-of-the-art 1D, 2D, and 3D numerical engines, and it's supporting tools for simulating free surface water flow. TOEFL is used by over 700 companies globally. This image is pretty old one, about 6 to 7 years back. At that time, there were only two. So these are the pink ones are the universities who use TOEFL for research. So at that time, only IIT Delhi and IIT Chennai were using TOEFL back in 2017. But currently, like most of the major IITs have started to use TOEFL along with some of the NITs and the central government organizations have started to use TOEFL for small scale flood studies to very large scale river scale flood studies like Krishna Ganga River as well. It is it's mostly it has originated from Australia, from Brisbane in Australia, called as BMT Consultants, and then it has moved to a lot of companies in UK and US, and across the globe, some other countries who are primarily using for flood studies. I won't go into much details about what is TwoFlow's heritage, but one thing I can say is it's very much an old software started back in 1972 when TwoFlow was introduced as a 1D solver called as S3. S3 is the 1D component of TwoFlow. It is not the name S3 has come because it was initially used for modeling estuarine environments, but the name has stuck in from then, and even till today, the 1D component of TwoFlow is called as S3. And this is when in 1989 to 1990, when the 2D solver of the TwoFlow was taken forward, and then from 1990 was when the 2D solver was very prominently used across Australia, and it is very much capable 2D solver with a huge number of like flexibilities, and the number of companies who use TwoFlow for 2D, say there like many solvers within the graphic interface who used TwoFlow's 2D engine. And 2001 was first when TwoFlow's sale was done. Initially, TwoFlow was not basically created to use for a commercial sale purpose. It was generally to support the internal business for BMT consultants. But when people have seen us using TwoFlow, the first request has come from UK office, and that is when the first commercial sale of TwoFlow was done. And 2002 to 2006, there with the flexibility of TwoFlow, there are variety of third-party graphic interface providers who use TwoFlow's engine inbuilt into it, and they have their own kind of interface with their own names. Like SMS has one of the component for TwoFlow engine. Flood Modeler also has it integrated TwoFlow engine. XP Solutions, XP Swim, which was historically by now it's part of Autodesk, but initially they used to have XP Swim, which again the 2D engine was TwoFlow, and 2D is more popular in Australia, which uses TwoFlow as its engine. And 2010, TwoFlow also has got FEMA approval. Uh, So, and in 2012 was when TUFLA was benchmarked against various environmental agency, which from the UK's all the tests were done to benchmark TUFLA for its speed and accuracy. So it was one of the major milestone in terms of getting TUFLA to be the best in terms of speed and accurate solver. I wouldn't say go into much of these. The first probabilistic Monte Carlo assessment framework was done with TUFLO and in 2015, and this project was a Brisbane flood study, which has won a lot of awards at that time. And 2017 was when TUFLO's HPC solver or the GPU component was first released, and that was when like all the new things which have come into flow, like large scale flood modeling applications was possible only because of this GPU integration. Like mostly that, before this, it was all like much smaller scale models, much more constrained in terms of flood modeling aspects. But now with GPU solvers, it's much more reliable, and also it's more kind of real time scale modeling was possible because of this. And TUFLO was very well known for is very well known for dam bridge generation modeling. I have been part of this large scale project in UK when I was working with a consulting big group. So there they have done all the 2000 major reservoirs of the UK using TUFLO. So they have specifically selected TUFLO for its features of being very quick, or the speed of the solver, as well as the accurate solver mechanism which TUFLO has. So this TUFLO HPC scheme was selected for the modeling of UK reservoirs for failure generation modeling. So this was the dam bridge generation model which I had worked with. I wouldn't, they like multiple, what are the benefits of having TUFLO knowledge in Indian scenario? Like apart from having a very good solver, which is robust, having is very quick and speed, in terms of speed and flexibility of model setup. There are many MNC companies who use TUFLO in India. Like me, myself, after my master from IIT Guwahati, I was really looking to get into one of these companies to get start into my water modeling career. So that is when I got into Mott McDonald was my first company. And they're like currently they're like huge demand for TUFLO modelers who know TUFLO with some mid experience in TUFLO modeling. They all are hiring for various projects in UK, Australia, US, and Europe. So there's quite a big group or big requirement for TUFLO modelers. Also, for students and researchers, is more likely to have multiple opportunities because you'll be having a common working knowledge of TUFLO. So when you go to abroad or when you're collaborating with the clients or with your researchers, so it is more easy for you to work with them if you are having a bit of TUFLO knowledge too. So I'll show you like why is TUFLO specifically or special in terms of flexibility of model build. So basically, what are the two products which TUFLO has? There are three primary products. One is S3, which is a 1D open channel flow for pipe networks, which I was saying for the 1D component. You can also have 1D structures like bridges, culverts, and everything as part of 1D. So this is TUFLO Classic or HPC is the fixed grid based one, which is again it's a square cells basement which has two components: GPU, hardware, and advection dispersion. And there's towards the right you have TUFLO FE, which is mostly useful for environmental applications like advection dispersion, sediment transport, water quality, and morphology. It is based on flexible mesh approach. So you have three solvers in this space. Like most generally for flood modeling, we use TUFLO Classic or HPC. One thing to note here is that if you are taking TUFLOW Classic or HPC, S3 comes for free. Like it is already inbuilt within TUFLOW Classic, so it's not being sold like separately. So essentially, there are two solvers. One is TUFLOW Classic or HPC, and TUFLOW FE. This is for coastal and sediment transport modeling process. So these are the three products which we have. And so like what sets TUFLOW apart from others? One thing is that all the team of TUFLOW are the users and developers of the software. In TUFLOW team, there it's not like the developers of the software are some computer programmers and the users are from the water resource background. Like they're the one kind of company where all the developers are also the users of the software because they use it for the consulting business. So we really know like what are the requirements as a user or the consulting works which we do. And also from the researchers point of view, we collaborate with a lot of universities to know what are the users requirement and what are the new research which is being done and try to develop it within our team. So that is one good aspect. And we are open to any new ideas. And if you want to really integrate TUFLOW into some of your codes and other things, we are happy to do that with a certain libraries as well. And also we listen to our clients and build features which they want. If you see TUFLOW release, almost every year there's a new release, and these are the features which some of our clients have suggested. So those features are being incorporated apart from our own research which we do in the team. So this is one. And TUFLOW has been extensively benchmarked for last 45 years in various university studies, internal studies, and industry assessments. So these are some of the reports which was done using TUFLOW, which was basically benchmarking against various studies. So you can go through these reports in the TUFLOW's website. And TUFLOW was also was done for real world calibration studies. Like there are virtually many of them, or thousand of them. So these are again done using TUFLOW's scheme, and these reports are again available in the TUFLOW's publication page. So you can go through these reports. So one specific area where TUFLOW really excels apart from others or any free source software or a much better commercial software is in terms of speed. Like put simply, TUFLOW is the fastest 2D shallow water solver available currently in the market. So again, this is not just out of the air. This was one of the um, uh, it was one of the study done by the UK's Environmental Agency. So this is a report. So they have tried to benchmark all the latest generation 2D hydraulic modeling packages for its speed, accuracy, and how flexible it is to get the model set up. So I'm just showing one of the test case called as test 7, which is somewhat similar to a real world case. So in this, they have really benchmarked an example model with TUFLOW Classic with one CPU. It takes 3.3 minutes, whereas Mike Flood with 8 CPUs, it takes 3.8 minutes. And Hecrus is way slower because of its schema and its setup. Even with 8 CPUs, if you're running with multi-core, it takes 34 minutes, so it's way much slower. And now with the recent release of TUFLOW GPU module, it is 10 to 100 times faster than TUFLOW Classic. So you can see that TUFLOW is fast, is quite quick in terms of its solution scheme, and it's more efficient. If you see in the actual code how it works, it's very fast and it's more easy to set up the TUFLOW model too. And also, it is exceptionally stable. So this is again a tsunami assessment. If you see, there are like huge water level gradients across a 2D model. So if your solver can predict such a huge water level gradients, it's about 7 meters high of water in a very good environment condition. So that is exceptionally stable in 2D. And also, it is very popular for 1D 2D linking schemes. TUFLOW is widely popular for 1D 2D linking in flood modeling area because the 1D 2D linking is very useful in terms of if you know that if you have this survey cross section of the channel and then you link it to 2D area, which is more realistic than just taking the channel from the LiDAR or DTM. So this 1D 2D linking is a big role in TUFLOW and it's very stable. You don't have any wetting and drying issues at all in your model. So usually most software solvers like which I have experienced in Hector's or even in Mike, so they have a lot of wetting and drying issues. Like if in a model, if a channel or a cell gets wet, the model goes unstable. But in TUFLOW, that is one of the things which I really like. It is that even if a cell or channel goes dry, it doesn't matter to the model. It runs the model in a very efficient manner. And there is an excellent error messaging capabilities. TUFLO is very much linked with GIS, QGIS shapefiles, or even geopackage files. So if there's any error or any warning or check file, it has to give to you. So it will give a proper check file which you can load in QGIS and see what is the check file. And also there's an error code. With that error code, you can go to the TUFLO's website and see what is the possible resolution for that error and try to have that interactive check for yourself. So it's not like very much of a black box. It is not very, the code is not very open, but still it's a quite a good kind of diagnostic checks which are there in TUFLO, which would really help for the modelers to move away from that black box kind of mentality. So that is where TUFLO also is really good. This is again the extent of tsunami inundation, which was done for a lab flow experiment. So this is a lab flow experiment where we are trying to study the extent of the flood extent due to a tsunami, I think. So this is the flood extent in a coastal town, and this is the model extent. So you see the black dot is the extent here. So it is very well matching here with the observed extent. So it is we can say it is quite well validated. So, and what I also really like about TUFLO is the model build flexibility. Initially, currently most of the people use QGIS because it's free source environment. And now, though TUFLO doesn't have a specific graphic interface, there's a plugin within QGIS where you can use it as a graphic interface, apart from having that benefit of having QGIS powerful environment for GIS functionality. So you're getting two things at once. And also there's mapping for ArcGIS you can use if you want to use in those environments. So you can build in any of these layers. And also you don't have to really have a license to build your model layers. Like unlike some softwares where you need to have that graphic interface license, you don't need to have any license for any of these. You can build your model layers. Only when you need to run your model, you need to have the license. So you can build the layers license free. Also the results, you can share the results to anyone. You don't need a license to read the results as well. It's all free source outputs like NetCDF, XMDF, and ASCII files, the rasters, or even CSV files. It's very simple input and output kind of format, which is the crux of the TUFLO modeling thing. As I said initially, there are a variety of third-party graphic interface providers. Like Flood Modeler has one component for 2D in TUFLO. TuvalD is a popular Australian software for drainage models and drainage design. XPSFIM and SMS Equavo. So they have the 2D engine built within them for TUFLO. So if you want to use that in those cases, you can use too. So this is the flexibility of TUFLO. Like it is so kind of widely simple and easy to integrate to any of the other third-party solvers because it's of its open-ended kind of nature. And there are a variety of third-party apps as well. So TUFLO QGIS plugin is one where the BMP team or TUFLO developers have built this plugin. So you can use this as a graphic interface itself within QGIS. It has all the features to view the layers and other things. So there's something like Batchy, Water Right, Trim, and TUFLO FEWS adapter, which you can use. And TUFLO also has an excellent support mechanism. If you're having any queries or if you need any support in terms of training, and especially in India now, since I'm there, I'm kind of training almost every 1 or 2 weeks to one of the institutes or even companies as well. So if you have any question or any need support in your model development as well, so it's very good thing in TUFLO support. So if not me, even the Australian team, if you email to the Australian team, so they'll be very happy to help you or resolve your issue with TUFLO. And also, the one good thing with TUFLO is that it's not a free software, but still it is much lower cost, say even a fraction of any other commercial computing software. And there's no licensing limitations at all in the model. Like the number of cells are unlimited 2D cells. You can have unlimited 1D channels, pipes, and nodes, and unlimited boundary condition inputs can also be given. So so the value you're getting for the cost paid is really good in TUFLO. And I'll just show you some of the modeling applications of TUFLO which I was using earlier. So you can see this is the 2D only model where these are the 4 locations in this site here. So we are trying to compare the 2D flood model result with the recorded level. So the blue dot is the recorded level and the red line is the model result. And across these four graphs, you can see it is very well matching. So this is what TUFLOW is really capable of to represent the real world hydraulics at the high level of accuracy mathematically. Like obviously you need to have your inputs correct here, like the DTM and the flood hydrograph and other areas. But you're getting a real nice calibration with the observed data. And across history, TUFA is very popular for 1D, 2D models. So this is a 1D, 2D model where you can see the 1D river flow path and you can see the how it goes into 2D. And then almost within very few instants, it comes back into the 1D channel. So this kind of flexibility in the very robust 1D, 2D linking scheme is very popular for TUFLOW. This is a very old animation, but it really represents how the 1D, 2D mechanism works. There's an out of bank flows, and after a certain distance, it comes back into the river channel. And so this is a zoomed in image of this area. So this is a zoomed in image here, which we have shown. And this is a very large catchment in Newcastle. Yeah, it's near to Sydney here. So so here we are applying like catchment based flows. So it is divided into multiple sub catchments, and we are modeling one of the river here or the creek, what we are seeing here. The other thing with TUFLOW is it has integrated catchment modeling scheme too, where we can model the underground stormwater network. So what you see in the red, like transparent red color, is the stormwater network, and we can couple it with the overland flows dynamically. So here, every single cell is applied a rainfall. So this is a rainfall runoff model. So we're not having any hydrology flows. We're applying a rainfall directly of total rainfall of 486 mm, and the infiltration is 2 mm per hour, which we are applying here. And now we are trying to route the flows in the stormwater network as well as in the overland area. You don't see every single cell as wet because we have applied a depth cutoff of 0.15 meters or 150 mm. We are applying the depth cutoff. So only beyond that, we are seeing the cells as wet. So we don't want to see every area as wet, which are very shallow waters. So, so the next part is in the same example, I'm just showing you a zoomed in image of one of the stormwater network. So this is the 6 pipes underground, and we're trying to see. So these results can be seen in the TUFLOW viewer or the TUFLOW QGIS plugin. You can see the flows on each of those pipes, and also the long section of these 6 pipes is shown here. So all these you can see, visualize these results without a license in TUFLOW QGIS plugin. So you can just share your results to any other person, and they can I can try to inspect these results in this way. So that is quite easy. And okay, yeah. So here with the advent of from 2016, this is when TUFL has developed TUFL GPU or the HPC scheme. So with this now we are able to do like very large scale catchment based flood modeling without having a hydrology. And this model is about it is quite a large area. You can see this is about 600 kilometers by 600 kilometers square of area. And the model we have run is about 400 million catch cells which for this model. And we have run this model for with a 30 meters resolution. So this model has taken 40 hours of simulation time. And this is a fully rainfall runoff model. So you can see every single cell as wet of all these 400 million cells. And so these kind of things we were not able to do earlier, post 2016 across the flood modeling space. But now it's more common. Now we are able to do actual rainfall runoff models and really represent in a proper way. So this is all thanks to the GPU, like in Silicon Valley when they have invented the GPU cards, and now uh, uh, it was initially invented for gaming purpose, the graphic GPU processing cards, but now we are trying to use that graphic processing capability to crunch the numbers. So we are trying to parallelize the calculations and then crunch the numbers at a multiple speeds. So we can with GPU we can really speed up the simulation by 10 to 100 times. So these are some of the benefits. And with this comes real-time flood prediction and warnings. So you can see, so this is the catchment where there's a huge rainfall, which we have applied across the catchment, and there's a huge water which drops in the catchment, and you can see the flood indexation pattern in this catchment. And this is again can be linked to various flood prediction systems like Flood Fuse, FEWS we call. and Flood Intel and others, any other third-party flood warning systems. I think in the similar example, in using this, there are two examples which I can think of currently. So BMT has done a project with the government of Bihar or FMIC to study the flood on the Bagmati River to set up the flood prediction and warning systems using Tuflo and flood fuse. So that is one of the project which comes to my mind in flood early warning systems. The other thing is in USA, the University of Virginia has set up a Tuflo model in the cloud, and that model will automatically get the rainfall data from the NOAA website. And if it processes a certain threshold, it will simulate that to flow, or it will initiate the to flow model in the cloud itself and generate the results as well. So once these results are generated, it will be automatically transported to the state highway department or the government authorities to take further actions. So all this happens in a very quick time. So there is just a automated setup which is set up by that university. So this is some of the examples of real-time flood forecasting which is being done. And Tuflo's very new release 2020 and all has much better benefits. Like you can vary the cell size within a single model. So where there's some of the pipe networks and road areas, you can go for a finite resolution to pick up the drainage features. And outside that area, you can go for a coarser resolution. So this quadry is quite useful for large scale models, stormwater and urban models. And like this is general Tuflo traditional scheme. So most software solvers use cell-centered scheme, but Tuflo also has 9 center scheme, like 9 point scheme, where it have 9 points across a cell, and the cell center is based on the storage of the cell, and cell faces are for the transfer of momentum from one cell to the other cell. So that is the traditional schema of Tuflo. And there's something called a subgrid sampling. So this is without subgrid sampling. So now with subgrid sampling, so this is a like traditional approach of two flow. It's a flat bucket kind of thing. So in this river, this is a river channel and this is a flood plain. So in this river channel, half of the cell is within the channel and half of it is on the flood bank. So if you take this cell, the conveyance is not well represented. So you either have to go for a lesser resolution of your cells or use subgrid sampling. Just tell you what is subgrid sampling. So now with 2020 release in Tuplo with subgrid sampling, you can create this kind of curve across the cell. So what it does is it will pick up the points within a single cell and create a cell volume versus elevation curve. So earlier it was a linear line, the cell volume versus elevation. But now with this approach, it is cell volume versus elevation is a nonlinear curve. And with this, you can go for a high. Now, what the benefits of this is that you don't have to worry about your cell size. You can go for 30 meters or whatever is this bit or cell size. You can go for a coarser cell size, but still get the proper accuracy in this model. So that is one of the benefit of subgrid sampling. And also there's like multiple benefits of subgrid sampling. You don't have to worry about your model orientation, grid orientation, and a lot of other things. And it's much more stable as well with this kind of subgrid sampling. And also Tuflo has implemented a new scheme for turbulence, which is called as Booth 3D. It is much better. So these are the different tests which were done in Tuflo by Tuflo team. The different lab flow experiments. So with a 90-degree bend and dam, break, flume, and Brisbane River. So they're just varying based on the scale of the model, from very small scale to very large scale, and trying to see which is an optimum case where they can achieve good parameter. So out of all these, they have done. So usually Smagorinsky constant is the most commonly used ones. So in historical Tuflo, he also uses the same one. But now from 2020, Tuflo uses Wood 3D scheme, which is excellent outcome, which it shows. And this is only used by Tuflo. It's not used by any other commercial softwares with this Wood 3D scheme. So that is also very good in terms of you don't have to really change the turbulence parameter for the scale of your model. Usually, if you use Fagorinski constant, it depends on the scale of your model. So if your scale of your model changes, you need to change the turbulence parameter. But here it's more or less constant. And Tuflo, as I said, it has inbuilt capabilities for real-time flood predictions. Like you can also have route closure locations and like you can also assign evacuation centers and evacuation routes. Based on that, it will show you what is the time it takes for the flood level to reach a property. So here it takes 10.5 hours, 9.9 hours to reach your property. So these are the properties. And what is the time it takes for the flight to reach a property? And it's, as I said, it is also compatible with flood early warning systems like Delft Fuse and Flood Intel. So it is very well suited for flood early warning systems. And there's a dam break. It's very so. This is a lab film experiment. You can see there is a dam here, and we are trying to study what is the effect of this dam break across this obstacle. Yeah. So if you we just intentionally put it at an oblique manner, so we want to study what how complex is the flow vectors or the velocities around these two areas. So you can see this 2 and 3 here, and we're trying to validate it with an observed data set. So we're trying to see what is the how is the water level changes across this point here, 2 and 3. So this is one. And Tuflo Classic or HPC or even Tuflo FE has an advection dispersion scheme. So if there's a pollutant which is dropped here, it routes down the channel. So it goes down this channel here. So this is the for studying any contaminant assessments for in those areas. And this is the something called as residence time assessment. So this is to study how this is much used for like any flushing studies. So this is a coastal lake in a coastal area, and we're trying to study how is this contaminant would affect in terms of the inflows or even the tidal flooding. So this is the tidal boundary which we apply, and this is the river inflows which comes in upstream, and we're trying to study how much is the concentration in the coastal lake, and which locations are they concentrated, and when would they be flushed out of the system. So they need to be get flushed out of the system here. So that is the residence time assessment, which you can study using Tuflo FE or even classic HPC. And Tuflo FE, now we are getting into FE side of things, which is mesh-based one. So you can see this is a mesh-based mesh, which is an outfall. And we're trying to study the contaminant assessment with a mesh. So you can see we have just added the contaminant on the top of the surface. And this contaminant we can study in the three-dimensional way as well as in the 2D area here. So this is the we have so TUFLO FE has a three-dimensional module as well, where we can study three-dimensional vectors as well as three-dimensional concentrations as shown here. And this is an outfall. So this is a coastal outfall which we are trying to study here. So this is again managed by the currents in the ocean as well as the waves, the contaminant. TUFLO FE also has like it is you can study the density stratified environments like when there's interaction between the salt water and fresh water in the coastal areas. So when this wedge is created, so it is the density stratification of the system can be studied and how this density stratification will affect other parameters like it will affect the water quality and also it will affect the way because of the density changes and the temperature, it will affect other processes too. So those things we can study. So this is especially useful for estuarine environments. That's when the saltwater and freshwater will interact. So the same example, so this is the so this is in I think in Melbourne. In Melbourne, I think this area is. So this is the river flow across this city, and this is the coastal area. So we're trying to. So this is the estuary. So we're trying to study what is the concentration of saltwater and freshwater across this estuary. It's about 18 kilometers of the estuarine environment, and we're trying to study what is how much extent the saltwater is being shown, and in the three-dimensional way as well. So it's not only in two-dimensional. We're trying to study in the three-dimensional way. What is the concentrations of saltwater and we're trying to match with the observed levels or the observed data. So this is the model data and the red is the observed data for salinity and as well as depth. You can see as we go deeper, the salinity increases because the salt water is more dense, so it gets settled in the bottom levels of water. So this is the wedge which forms here. And so one thing is studying the temperature and salinity effects, and but the other thing is how does these salinity and temperature would affect the water quality processes. So these are the water quality processes which can be studied with TUFLOW. This water quality is AED, which we are calling aquatic ecosystem dynamics. So this was a separate solver. It's a research solver which was developed by Matthew Burns in by the University of Western Australia. And it was quite popular and it's very robust water quality module. And now TUFLOW has integrated that that water quality module into TUFLOW. And now we can run TUFLOW dynamically with the hydrodynamic can be set up with TUFLOW, and it can be linked with water quality module. So all these processes for organics, inorganics, phytoplanktons and zooplanktons can be simulated, and how this is affected by the atmospheric fluxes, tidal forcings, and the temperature from the sun or from the solar radiations. And all these things can be studied in very detail with TUFLOW water quality module. And TUFLOW also has a natural like sediment transport area, so we can study this is the coastal dredging scheme where we're trying to study what is the effect of sediment movement with dredging. So this is a natural sediment without dredging, and this is a total sediment with dredging. So if you just do it in a post-processing manner, total sediment minus natural sediment, you'll get what is the dredging part of sediment here. So this is TSS, total suspended solids across. So at certain point there was dredging which happened in this period of time, and due to that there's a rise in TSS here, and we are trying to match that with the observed data. So the red dots is observed data, blue is the model data, and we are trying to. So TUFLOW also has a three-dimensional sediment transport feature where we can study what is this three-dimensional sediment deposition profile, and this is the model profile in three dimension. So yeah, and TOEFL we can simulate both the cohesion as well as non-cohesive sediments in the same model. So that is one of, and also each of the particles can have its own mechanism of sediment deposit. They're like different sediment features. Like it can have its own sediment deposit mechanism or sediment mechanism, which can undergo from the forces of hydraulics. So can go for these. And TUFLOW is also quite well used. So this is in eastern coast of Australia, northeastern coast, where we're trying to study the cyclone inundation. So we can study the cyclone path using our standard cyclone trajectories and how this influence the tide levels in the coastal areas. We can study that. So we can also apply the wind and pressure systems in the TUFLOW FE model, which will again simulate the water levels or affect the water levels in the coastal areas. So this cyclone, hurricane, typhoon, storm modeling also can be done with this. So we're trying to match the water levels due to cyclone event. So there was a cyclone event during this period. We're trying to match the water levels in this area. There's an example as well, which we can do it freely with for the cyclone models. So this is all with TUFLOW FP. And I think that's all from my end. I've just shown you some examples where we can do with TUFLOW and what is TUFLOW and what are the engines and what are modules TUFLOW has. So this is all about from my end till now. I will just leave it open for discussions. Yeah.
Thank you, Rishi. I think it was very interesting to see the applications.
So yeah, thank you. Yeah.
I'll ask the PhD students to ask any questions.
Yes. Is my video visible?
Yeah, we can see.
Okay. Yeah.
Hari?
Yes, sir.
Yeah.
Do you have any questions?
Sir, as of now, I don't have any questions. And the nice interaction with the Rishi sir. So it's a great interaction with him. And as of now, we are actually I'm working on Hackeras. So it's by seeing your presentation and everything. So I can work on this software, sir. It's very it's user friendly, as you said, and with the process and everything. So by your presentation, so it's very enlarging lecture and very detailed lecture. So it's very useful for everyone. So thank you, sir. Thank you for giving this interactive lecture. And definitely, I will hopefully I will definitely work on this lecture, sir, in the future, definitely. So if I'm any kind of regarding doubts and any kind of problems, and then definitely I will ask Anand sir and Rishi sir as well.
Yes. Yeah. You can get in touch with me. And so Hackeras, you're using 1D model or is it 2D? 1D 2D model.
Sir, sir, both, sir.
Okay, so 1D 2D model, right? Yeah.
Yes, sir.
Okay, that's good. Yeah. Yes.
Thank you, sir.
Yeah, thank you.
Yeah.
Yeah.
Anurag, yes.
Yeah, hi, Indra. Good
Yes, yes, sir.
morning. Good evening.
Sir, little bit about what are the differences between HACRAS modeling and your TOEFL modeling, sir? Like what
Yes,
are the
yeah. So, mhm.
yes,
uh, yes, yeah. So the main difference lies in the scale of modeling. Like for usually in hackers for like smaller scale model, it looks okay. Say the area of a 5 kilometer square or 10 kilometer square area. But here in terms of accurate modeling and as well as large scale flood models, so this TOEFL is much easier because it's GIS integrated and we can do a lot of automations as well with TOEFL. When I go into explaining the details of TOEFL, we can do like multiple scenarios, events, and also it's like we can do. It's more robust in terms of stability. Like I recently had one project which I was working with NIH2. So they had a HECRAS model which was very unstable. They were not able to run the model because at some point the water goes as a dry cell. Like the channel itself goes dry during one of them. So what is like in total, one of the things is that the channels can go drier but at any point of time. So that is one area, and also the tributaries and all as the model complexity increases. So it is much more robust in terms of easy of getting the linkages and doing the advanced kind of river hydraulics. So it's much more efficient. So those cases it is very good. So for very small areas, it might look almost similar kind of thing. Say 5 to 10 kilometers square of area, but very large areas and all, this kind of advanced things are required, especially the rainfall runoff and the 1D2D linking scheme. Like you can have in hackers, I think when I had just interacted with students in India, so we can't really have very large 1D2D areas. Like say going for 200 kilometers square of 1D2D model, you can't have only at some specific areas where they're trying to do 1D2D because they can't really do that full area of 1D2D across the river. So you're modeling like Krishna River. So you can't just have all from the starting to end as a 1D2D model. Which locations you want that 1D2D, you're adding that. So, but in TUFLOW, it's very easy just to have the across the 1D2D area, across a very long stretch to have that 1D2D scheme. So these are some of the benefits, and obviously the speed is there because we can go for with GPU integration and TUFLOW itself, the classic engine with CPU itself is very quick and fast. So I was recently working on one model where across 1D model only was taking about 40 minutes time for about 300 kilometers stretch of river. But in TUFLOW, it was just completed within 1 minute. And also so that is quite efficient because these things happen because any hackers or even other softwares has the graphic interface, and sometimes the graphic its interface itself slows down things. But in TUFLOW, it's more of like small like lower language kind of things like CSV files, GIS files, which are easy to create, set up, and read by the solver. So what TUFLOW team focuses is they try to focus on getting the solver done rather than focusing on getting the interface and other things done. So that is what some of the differences. But there are like other differences too. But you'll know when you
in
get to work. Yeah.
sir, one more thing, sir. Am I
Mhm.
audible, sir?
Yes, yeah, you're audible. Anurag. Yeah.
Basic input parameters in TUFLOW software, like in
Mhm.
HACRAS, we give digitalization model. So in TUFLOW also we have this
Yes,
model.
it's the same thing. So the hydraulic things are same, like what are the inputs like DTM and flow boundaries. So there you might be giving in terms of with the graphic interface, but here you'll be giving in terms of CSV files as well as shape files. So that is a difference. So the way you give might be different, but the standard inputs for any hydraulic model is same. So you'll be using the same ones. Yeah.
More things, sir. Sir,
Mhm.
of sir, the sources of digitalization model, sir.
Okay, yeah, the source of DEM. So it's actually required. It is defined by the area of which you're working. So usually, for large scale models like the 30 meters, the global scale Copernicus ones are okay enough to work with. But if you want more precise with the river models where the rivers are moving from the original locations, so you need to do more of detailed kind of analysis. Like people do surveys of the cross section or even LiDAR survey they do to get accurate ones. So it also depends on the DTM. So you can take
Uh,
whichever is proper. You can take
sir,
from the global source.
okay.
Mhm. Yeah.
Sir, I think according to me, sir, actually I have worked something on HACRAS related to some flood modeling. So
Okay,
I take
yes, yes.
SRTM digital model, 30 meter
Yes,
by 30
the 30 meters. Yes, yes.
condition are Indian river condition. There are the rivers are not at that location where the river is present at today's scenarios. Like
Yes, yes.
so, the river in digitalization model is not at that place where the river is at today time. So,
Okay.
can that's
Mm-hmm. Okay, yes, yes. So, so one thing is you can do in TOEFL is that it's very easy to do topographic changes. Like usually, if you want to do any, say, plus you need to give DTM. So again, you need to take the old one and maybe change the DTM in the GIS like that. Just change the DTM from that river line and all. So you have to draw again new DTM. You have to create your own DTM properly. So that is one method which they do. But in TOEFL, it's very easy to say you have the old DTM. Say in 2015 you have it old DTM, but now the river is very much changed. So what you can do is you can do if there's a
Sir,
new LiDAR or
sir,
survey, you can recreate it.
sir, sorry
Yeah,
to,
yeah.
so sorry to
Yes,
interrupt you,
yes,
sir.
yeah. Yes, yes,
Actually,
yeah,
sir,
yeah.
actually in SRTM, so we have the digital edition model is about 2014 itself. So from the 2000,
Yes,
from
yes.
2004 on the 2014 data it's showing actually. So
Okay.
from the 2014 to the 2024, till in the 10 years of span, so the many activities are has been done in the river and around the river. Okay, sir. So,
Yes,
so
okay.
those activities and those newly added things are not shown in this that SRTM DEM actually.
Yes, yes, yeah.
So
Yes,
so how do we incorporate those things in that real time scenario? So how will we
okay.
incorporate those things?
Yes, yeah. So on this in the same thing, so we have old DTM. So we'll take that old DTM, and in TOEFL it has a layering approach. Say you have old DTM, and you're trying to apply any new features. So you just have to add those features on below that. Like you need to read it below that. So it'll automatically recreate that DTM. So you don't have to again do it, have a new DTM. So suppose if there's any wall which is built newly, so you can impose those walls or whatever is the river channel paths on the new DTM. You don't have to do in GIS. You just have to give what happens in the GIS files only. So once that is done, it will create its own DTM. In Australia or any places, they do pre and post development of these sites. Say in the previous case, there was no development, any buildings and all, but now they are building. So it's just a matter of applying those new building layers. So you just have to do it manually. So you have to do either from the survey, you have to do a survey of those new things and incorporate that into Flow. So it will create a new DTM for you itself. Like you don't have to really get the new DTM from any other source. You have old DTM, you have to superimpose the new features one by one. So that is
Sir,
the only
actually,
method where you can do
yeah,
it.
actually, my area is around like more than 30,000 square kilometer area. So
Uh-huh.
for me, it's very hard to find those things for throughout channel, right? So it's very
Uh-huh.
hard to find
Yes,
me.
yes. Yeah, yeah.
So
Uh-huh.
so for that reason, if any like if it
Uh-huh.
is are incorporating the real time scenario into directly, so if it is good for
Uh-huh.
me, right?
Okay, okay, yes, yeah. So in those cases, I think some people use the remote sensing data. They digitize some features like over time how what are the new features which are coming. So there's a tool in QGIS where if you supply different images, so they do some image processing and then try to identify automatically what is the new things which have come in, and then and even just change the shape of the river, how it has changed. So those things it will do some automation for you, but you just have to be careful of what it is done and all. But you have to do it. Maybe the best way is only the survey only. So you have to get either like LiDAR survey done or the manual survey which is to be done like that. And then we can do
Yes, sir.
that. Yeah, yeah.
Sir,
Otherwise, it's
yeah,
not.
sir, as you said, like
Uh-huh.
in the TOEFL itself, we can have the hydrological modeling, right?
Yes, yes, yeah, the hydraulic
So,
modeling, and we have to get the
example,
hydrology flows. Yes.
hydrological modeling in the
Mhm.
sense say that if you will give the like rainfall data from the as a
Mhm.
CDF net CDF or CSV file,
Mhm.
so
Yes, yeah.
throughout area, so
Mhm.
we will get the discharge in that stream, right?
Discharge in this in
So
that area. Yeah,
in that
correct.
area or
Mhm.
in that
Mhm.
flowing stream. So, sir,
Yes, yes.
do we give only single file for a throughout area or?
No, we can vary it. Say, for example, we get the AMD dataset in NetCDF format, so we can read it directly into TOFlow without changing any other things. So we can directly read that .nc file. So a .nc file is spatially varying as well as temporally varying. So it will apply
Yes,
that
sir.
rainfall across
From
that.
year to year, it's
Yes, yeah.
varying
So
from
we
year
can
to year.
apply that very. So that's one of the best strengths of TOFlow. We can directly read that NetCDF file and apply it the NetCDF varyingly in that area. Or else if you have your own hydrology data set, like if you have HMS, .sdf, I think, of those .hms file, you can read it directly in and TOFlow with that HMS file. You can link it with TOFlow. Also, if you have Swim, I think Swim is also for stormwater and all. So if you have any stormwater Swim model, you can integrate it with TOFlow. Like Swim integrates directly with TOFlow. You can do stormwater network as well as like it's more popular in US, the Swim model. So if but that doesn't have 2D inundation area. So to integrate that, now we TOFlow also integrates with Swim, and we can do stormwater modeling with TOFlow too with Swim. So that is some of the things which we can do. As yeah, to answer your question, we can read that NetCDF files or CSV files like that. It's a very simple format to read the hydrology flows or in rainfall flows in .NET file format. Yeah, yeah.
Okay, thank you, sir.
Yes, yeah. Mhm.
Any other questions, Anurag?
No, thank you, sir. Sir,
Yes,
let
yes,
it
yeah. Mhm.
sir, is like in Hackras,
You
just
can ask, yeah. Mhm.
there is a tab, sir, where we can modify the terrain. Is that
Yes,
in
yes, yeah. Yeah, yeah, like the same thing which I have said. Like you read the first, you have in Hectors you have tabs to modify the train where you draw some break lines kind of thing. So here in TOFlow, it's kind of layering approach. You can read multiple DTMs. So what if you have the DTM one below the other? So the one which comes below will overlay the top one. So you have 1 meter resolution on the below one, and above you have 30-meter resolution. So the area which you have 1 meter will be automatically replaced by that 30-meter area. And if you have any road, if you want to draw, you draw your shape files and all. And wherever that road elevation is, it will impose on that 1 meter one. So it's kind of layering approach. So the same thing how you can, but it's much more easier than in Hackers one and much more robust, easy also in terms of like terrain modification. So one of the strengths of TOEFL is terrain modification, like how easily you can do with GIS, because most data sets you get in GIS format. Like let it be like LULC values, LULC layers, or any government or any world data sites is in form of GIS. So it's just a matter of getting the GIS into TOEFL format, again a GIS file, and it's easy to read it into TOEFL. So it's very easy to set up the models. And it's like what I find is in future also the flood modeling is dependent on GIS integrated flood models than its own proprietary kind of flood models. So that is more in future kind of thing which will happen. Yeah.
thank you so much, sir. Thank you.
Yeah. Yeah. Yes.
Thank you, sir.
Mhm.
I have one question, actually.
Yes. Yeah. Yeah. Yeah.
You mentioned TOEFL is very fast compared to other models.
Yes. Yeah.
How does it compare with ListSlide, for example, where
This
they
flood.
have
Yes.
1D to
Yes.
D combined approach, or even
Yes. Yes.
HECRAS?
Yeah.
I think they do 1D to D combined approach.
Yeah. Even they
Is
have
it
like
faster
only
than that?
2D. So it's definitely much faster than Hacker's. And ListFlood actually it's not a full 2D shallow water equation. It is like on a broad scale one. They don't have one of the component. Like in Hacker's you have kinematic component or even full shallow water equation kind of thing. But in TUFLOW, it's always full shallow water equation. And coming to LISFLOOD, it is like the inputs are it's slightly faster because its inputs also is kind of CSV and kind of open formats. But it's not a full shallow water equation. It's not a full flood model. It's more for broad scale model, like countries level kind of model. If you want to do like for across country, they do very broad scale models. So that is where LISFLOOD is being used for very large scale country scale models. But now with TUFLOW also we can do country scale models with GPU and other things. So we can do much detailed as well as broad scale models with TUFLOW. So obviously TUFLOW is much faster than HEC-RAS, and even LISFLOOD I have never used it, but I know that it's not a full shallow water equation solver. It's only it doesn't consider momentum of water in the shallow water equations, like 2D shallow water equations. If you consider one of the component, it doesn't consider. Yeah.
Have you met anyone from IIT Madras?
Because yes, I've been talking with them. With the civil or water resource department.
Civil, Professor Saumendranath Puri.
Yeah.
Because they are developing a model.
Yes, yeah. So even he has, the professor has the TUFLOW model. In 2017 only they have purchased it, but much before I come. Yes. So they use TUFLOW. Professor Saumendranath Puri said, yeah.
Okay, because now they have come up with their own model and they're claiming it is a faster model.
Yes,
but
yeah,
I don't
it
know
was
if
there.
they have compared it to TUFLOW.
Yes, I'm in touch with them. They're trying to do it. Yeah. It
they
was
compared
good
it with
too.
LISFLOOD.
Oh, okay. Yes. So it was good. Yeah, they published one paper, I guess. Or posted in website. Yes.
Yeah, but I think once we have the GPU acceleration, then whatever they're developing may be still slower than
Yes,
TUFLOW and
it's a bit
GPU.
difficult to do GPU. That is a main. It takes some time to link it to GPU. But I think HEC-RAS also maybe after 2 years they're planning to get into GPU space. Maybe 2026 they said in the recent release. But it's a bit tough to get into GPU areas. But in TUFLOW they had got it from 2016-17, so that it has grown from that time.
So are there any drawbacks or limitations for TUFLOW that you can think of?
Yes, yeah. So drawbacks. One thing is like some people prefer having hydrology also. Hydrology model setup, like how we have HMS and HEC-RAS. So in TUFLOW, like what happens in Australia is that like they have Australia, other UK, like other countries. So they have like kind of good details to have rainfall runoff models. And now with TUFLOW speed and all, so they're planning to do rainfall runoff models more often than develop a hydrology model within TUFLOW. So you have to either it's already integrated with HMS or even SWIM and all. So they don't really plan to have their own hydrology model, but like it's for users to have their own other from hydrology from other areas. And it is already incorporated into TUFLOW. Like you can read the .spf files from HEC-RAS into TUFLOW for hydrology, but not specifically. They don't have any specific plan for hydrology in TUFLOW because they use directly rainfall runoff model and these kind of other things because they already have like many more hydrology models in space. So they don't really plan to use hydrology for now. So that is one thing. So like some people in India feel that we need hydrology as well. But apart from that, the graphic interface sometimes because like sometimes the graphic interface it's okay for some few things, but having the graphic interface itself have some difficulties in setting up the model and other things. Like this, it slows down the system and a lot of things are there. But TUFLOW has graphic interface in terms of QGIS. So you always need to be good in QGIS or at least have some knowledge of QGIS to use TUFLOW. So that like if some people are not used to QGIS, they might find it a bit difficult than having graphic interface. So that's one of the things. So that is all, yeah. But it has a lot of other advantages because of that. There's a bit of playoff here.
Does the pricing vary with the platform that I choose? Like if I choose QGIS or SMS or something else, does the pricing change with that?
No, it is same thing. It is same. So TUFLOW they suggest as the engine. So that engine, so let's say so it's all within QGIS, which is again open source, and ArcGIS there's a toolbox which you can use, which is again freely available. So TrueFlow team does the engine part and the free tools which are available in other GIS platforms. Like if this thing is being sold by SMS, they charge their interface as well as TrueFlow license, so they do it separately. But what TrueFlow team does is they just sell the engine part of it. So if you are purchasing from other vendors like SMS or TrueLD and all, so they sell it adding to the graphic interface. So that is the one. But now we don't really need graphic interface because QGIS itself has become a graphic interface kind of thing with TrueFlow plugin. So it's not really required to have a new graphic interface kind of thing. Yeah, that's the idea. Yeah.
Thanks. And any other questions? I think there are no more questions, but thank you so much, Rishi.
Yes,
it was very interesting
Thank
for
you,
me to
Professor
learn the
Yeah.
capability.
Oh, yes, yeah. Thank you all for your questions too. It was nice interacting with you all.
Thank you, and I'll keep in touch through email or WhatsApp.
Yes, yeah.
Because I
we'll
want to know more details. Yeah.
Yes, yeah. We'll talk. And I think for all of you as well, there's a demo mode too, which you can use without license and all. You can so there's the example models which there are about 150 example models in TrueFlow which you can run without any license. You can do all those tests and all. And for your own models, if you want, there's a 1 lakh cell limit. So with 1 lakh cells is quite a big amount in some cases. So you can set up the model with a coarse resolution of 1 lakh. So if you have 30 meters DTM, you can take 30 meters cell size and 30 meters for 1 lakh cells you can take it. So that's quite a reasonable amount. And with GPU, you can really run a large amount. So you can use all the features of TrueFlow in the demo mode, but just one limitation is 1 lakh cells is the limit for demo mode. So can you start using that? And so it's available for all your models, coastal or flat too.
Is there any time limit on the demo mode? Like
yes, yeah, there's
a duration.
There's a if you can run it for the simulation time, you can run it for anything, but the time it has to complete within 10 minutes, I think.
Okay, but the duration for the license itself, is there an expiry period?
No, there's no expiry period. Like anyone can use it for any time. Okay. It's like a student license, just for trial license or whatever it is, kind of that.
Okay.
So you can use that. And is a CPU, like how much time the CPU takes to run? So if you have a good GPU system, you can run it within the 10 minutes. You can run much bigger model too. All things can be done, and all the features can be done, like subgrid sampling, quad-tree, cyclone models, stormwater, and groundwater also is a new component for groundwater. You can have groundwater infiltration, and it can route in the groundwater itself. So it's not like full groundwater component how GMS does, but very basic one to capture subsurface flows, like the interaction between surface water and subsurface water. That's the main part, rather than very much diving into groundwater modeling. So those things can be done with this demo mode. So you can set it up any rough model as well, and I can maybe help you to set up that, and you can understand how it works and everything. Or even I'm happy to convert some of your models if you're already having something else, like cyclone models. So say I'm happy to convert it into TrueFlow FP. That's how I worked with other institutes too. Like I convert some of their models and they to explain how it is better and what are the benefits and pros and cons, so that we can do too. Yeah. Yes.
Thank you.
Yeah. Okay. Yes.
Thanks. Thank you once again.
Thanks everyone.
Thanks so much.
Thank you. Yeah.
See ya.
Okay. Then bye.
Bye.
Bye.